In this week's assignment, we are going to continue using Google Sheets. Although we are going to move away from using it as a ledger and as a calculator for data, but rather we're going to look at it as a financial tool. So one thing that you may run into whenever you have a farm or a ranch or an agricultural operation is eventually you might have to acquire a loan. It may be an operating loan, it may be a vehicle loan, it may be an equipment loan, or it might be a land note or something of that nature. So what we're going to do in this assignment is we're going to look at Google Sheets and use Google Sheets to create an amortization table. What that really is being able to calculate loans. So let's go ahead and dive right on in. Right now, I'm going to go ahead and delete these three cells. We have it kind of set up. And we're going to say that we're going to be dealing with a loan that has a principal value of, we're actually going to put this in dollar amount, to decrease the decimals, of $500,000. So let's say this is a $500,000 land note. And we figure out that the percentage is 1.97% APR. We're going to take, say, 30 years to pay it off. And then on top of that, the payment per year is one time. So you make one land payment per year. That might be the case in some agricultural loans where they set it up where you receive one payment per year. That would make sense, especially in an agricultural loan, when often a farmer or rancher only receives a check one time a year. So to create an amortization table, the first thing you need to do is you need to set up these constants up here. You want to say, all right, principal, your interest, the number of years that this note will take to pay off, and how many times are you going to make a payment per year. Then you want to set it up where you have these categories down here. You want beginning balance, total payment, interest payment, principal payment, and ending balance. So you want to make sure that you have all of these in place and go ahead and set up your constant values there before you really start calculating some of these values. So once you have this table set up, the next thing we're going to do is we're going to start actually calculating this amortization table. Now, if you have a $500,000 note and you're paying it off over 35 years, it might stand to reason that you could say, okay, well, you can take this $500,000, divide it by 35 years, you're paying it one time a year, so you're making an annual payment of, say, $14,000. That might be a logical way to think about it, but then you have to include the interest. Whenever somebody makes out a loan to you, they often have an interest rate, or they will have an interest rate that is actually compounded. And through the use of compounding interest, this payment, where without any interest, if it was all cash payment over those 35 years, because of interest, that payment is actually going to be slightly higher. So whenever you're going ahead and creating this amortization table, the first thing you want to do is you want to set up your beginning balance. Well, in year one, what is your beginning balance? Well, it's equal to the price of the loan. So we're going to go ahead and we're going to say equals, and we're going to cell reference this principal amount right here. So then we go to the total payment. To calculate the annual payment, or this payment on this loan, you're going to use a formula, a financial formula that's embedded in Google Sheets. And to access this formula, you type in equals PMT and then open parentheses. Now, we have this formula set in there. And if you ever type in a formula but you're not quite sure how to use it, there's this little question mark right here. Click on that question mark and it'll tell you how to do it all. So the payment formula is equal to operate the payment formula. You say the rate, which is the interest rate, the number of periods, so how many times will you make a payment, what is the present value of that loan. So in this case, that present value is going to be that principal amount. And then it has some other stuff that we're not really going to deal with. So we're going to go ahead and type in the rate. Now the rate is equal to this interest rate divided by the number of payments per year. So in this case, it's going to be 1. So it's going to be very important that whenever you deal with these APR, these interest rates, to find the interest, you take that interest rate divided by the number of payments per year. It becomes critically important whenever we start dealing with monthly or quarterly compounded interest. In this case, we're just dealing with annual interest, and it's not as big of a deal. But later on, when we get into the next part of the video, we'll talk about how that becomes a big deal. So, these are both constant values that never change. So we want to go ahead and lock both of those cells in. So I'm just highlighting those two cells, and I'm pressing F4, and as we know, that locks in those cells. Now, the next thing we want to do is after we find that rate, we want to say comma. Then it says the next thing is the number of periods. Well, the number of periods is equal to the number of years times the payments per year. Again, we want to lock in both of those. Again, this not that critical to multiply the year times the payments per year here, because we're only making one payment per year. But later on, whenever we start dealing with quarterly or monthly payments, you're definitely going to want to take those number of years times the payments per year. So then the next thing is it's asking for this present value. So this present value is this principal value right here. I'm going to go ahead and click on that principal. Again, we're going to lock in that cell and close parenthesis. And now we see that we have this negative number. Well, because of the way the payment calculator actually works, it's going to throw off this negative number. In order to correct that, what you want to do is you want to come in right here, right before this present value, and just type in a negative. And then press enter. So now we can see that the payment per year is going to be $19,907.13. We can see that that is a far cry different from this $14,000 if there was no interest altogether. So this number now becomes irrelevant. It was used just to show you an example that when you're dealing with interest and compounding interest, you are paying a lot more. Now, the reason that this present value was actually becoming, was thrown without this negative sign in front of it, remember how it threw off this negative amount? Well, the reason that that actually occurs is because you're already $50,000 or $500,000 in the hole. You took out a loan, you owe $500,000. So because of that, this is actually a negative amount, making that payment now positive. The next thing we want to calculate is the interest payment. So you're paying $19,000 every year, almost $20,000 every year. How much of that goes to interest? Well, in this first year, we can find that out by saying equals. We're going to take this beginning balance times, we're going to go ahead and open parenthesis, this interest rate divided by the payments per year. And we want to go ahead and lock in those two because those are our constants that are never changing. So we'll go ahead and lock in those two. And then we want to go ahead and say close parenthesis. Now it's very important that we want to take the interest rate divided by the payments per year. And you've seen me reference that a couple times in this video already. The reason that becomes very important is this 1.97% is APR, or annual percentage rate. If we're making multiple payments throughout the year, that annual percentage rate actually gets cut by the number of payments per year. But because of compounding, it actually increases the amount that you'll eventually pay. So to find your interest payment, you take the beginning balance times the interest rate divided by the number of payments per year. And you can go ahead and say enter. So what does that mean? It means you're paying almost $20,000 a year in a payment, and your interest on that first year is almost $10,000. So out of this $20,000, almost half of it, or actually half of it, winds up going to interest. So whatever is not going to interest is actually going to the principal of the loan. So the principal payment is actually equal to this payment, that yearly payment, minus however much is interest. So you see that $10,000 of the $19,000 that you're paying is actually going to the principal, paying off the principal of the loan. So then you say, all right, well, the ending balance, meaning what is, after you get done paying this, what is the ending balance of that note? So at the end of year one, the ending balance is equal to this beginning balance minus this principal payment. So at the end of year one, and I'm actually going to throw in another column right here, and what I'm going to do is I'm going to right click on this A and say insert one left. And I'm going to type in right here term. And this is actually how many payments. So for this first payment, that first year, we actually want to put that in just plain number form with no decimals. Saying that for that first payment, when you write out that first check for $19,000, at the end of that first check, you only owe $489,000 and some change. So on the second payment, you go to make this second payment. Your beginning balance is now equal to your ending balance on the previous year. Now your payment doesn't change. You're going to make the same payment every single year, the same amount in payment every single year. So you can go ahead and drag that one down because the payment stays the same. Interest payment, because we locked this in, we're going to go ahead and drag that down too. Now what is that saying? It's saying that the amount that you are paying in interest is equal to the beginning balance times the interest rate, the APR, divided by the payments per year. So you can see that this interest actually falls. The interest payment actually falls. The reason it's falling is because your beginning balance is falling. So what you see on these loans is as you go on, your interest payment begins to fall, but at the same time your principal payment begins to rise. So what happens is in that first year, a lot of that payment goes to interest. Second year, a lot of the payment goes to interest. But as time goes on, that interest payment falls, and the majority of the payment will begin to go towards the actual principal on the loan, allowing you to pay off the actual note. So after we get that done, we want to say, all right, this is equal to, or the number of terms, which is how many times you're going to make a payment, is equal to the number of years times a payment. So in this case, it's 35 times 1. So I want to go ahead and drag these terms all the way down to 35. We're almost there. So we want to drag it down just 5 more spots. 1 more. So that's how many times we're going to make a payment. We're going to write out a check 35 times for this land. So now that we have everything set up on the second row, an easy way to do this is you can highlight this second row and just the second row and drag down. Then you can drag it down all the way to 35. Now what we see here is as we go down and we look at this interest payment is falling. You can see it's in the 9,000s, upper 9,000s, lower 9,000s, 8,000s, 7,000s, 6,000s, 5, 4, 3, 2, 1, and then it's down below 1,000 on these last couple years when you're paying that amount. But as you can see, the principal amount is going up. And through the whole time, you see that this ending balance keeps falling. So what you would like to see at the very end of that 35 years, or that the end of the payments, you want to see that ending balance equal to 0. If that equals 0, then that means that you have done something right. That means that you have accurately calculated this amortization table, provided you have all of the formulas right. Now that you have this amortization table, you can now see how many years it takes you to pay off everything, what's going on with your interest payments, your principal payments, what's going on with your ending balance, and everything of that item. So now we want to calculate, for example, yearly payment. So the yearly payment is equal to how much are you paying in per year. So this is the payment per year for this particular example because we're only making one payment per year. But what if we were making quarterly or monthly payments? Then we would actually take the payment times the number of times we pay per year. So there's two ways to be able to calculate yearly payment. The first one is we can say this is equal to the payment times the payments per year. That makes sense. Another way that we can say it is we can say, all right, we want to find what is the total amount that we are going to pay. So we can say this is equal to the sum of all of the payments. And all I'm doing is the equal sum means just add up all of the payments, or add up all of the numbers being highlighted. I highlight all of the payments divided by the number of times we pay. So the number of times we pay is equal to the years times the payments per year. Either way, we come up with the same number. A simple solution is just to say this is equal to a payment times the number of times we pay per year. The total payment is going to equal to the sum of all of the payments. So in order to calculate this, you can say equals sum, meaning just add up everything. You can see that sum means return the sum of the series of numbers and or cells. So then you can just add up all of these payments. And that's going to tell you exactly how much you pay total for that land. So we can see right now that the total payment, the amount that you paid on that $50,000 or $500,000 note, is actually $696,000. Well, why is there an additional $196,000 over and above the total payment or the principal balance on the note? Well, that's due to compounding interest. So to find the total interest, you say this is equal to the total payment minus the principal amount. So what we see here is that each year you pay $19,907. You're going to wind up paying a total of $696,000 on a $500,000 note and a total of $196 in interest alone on this particular note. Now that we've created this amortization table, if we had to take out, say, a $500,000 note at 1.97% interest rate, we can now accurately be able to tell everything we need to know about this note, including how much are we going to pay in total, how much is it in interest, what is the principal amount, and then also how much each and every single year is going to, or each and every single paycheck or check is going to the actual principal on the note, how much is going to the payment or the interest payment. Now that we have all of this done, let's go ahead and see what happens whenever we change the parameters a little bit and say we're not dealing with a yearly note, we're dealing with a monthly note or a quarterly note. Now the good thing about Google Sheets is that once you create it once, you don't really necessarily have to create it again. So I'm going to show you a little, more or less, a time-saving method of being able to do this. Now, for you to be able to do this and do this effectively, it requires this first sheet to be 100% correct. So before you go on and make the second sheet using the method I'm going to show you, I want you to go ahead and double check all of your formulas to make sure that everything is looking correct, so that way you don't have to go back and fix it on 2 or 3 different sheets. So after you make sure that everything is correct, what I want you to do is I want you to come down here. I want you to just say duplicate. So now we've got a copy of land note, and we're going to actually rename this. And let's call this truck note. Say you go out and you buy, oh, I don't know, a $45,000 truck. And you go into the dealership and they are giving you an interest rate of, I don't know, let's say 5.79%. Now if you don't, and as you can see as I'm typing in these numbers, it's automatically recalculating things down here. It's recalculating things because Well, it's all of these formulas are based off of the numbers up here, these constants. So we have an interest of 5.39 or 5.79%. Now, something to note whenever you're dealing with these percentages. A 5.79%, if it was written in decimal formula, it would look like this. So this is written in percentage formula. This is written in basically plain number. So if I were to go up here and I take this interest and I go back to, say, number right here, it's going to look like that. 0.579. So don't get that confused with saying, all right, this is actually going to be 5.79%. Because that is not correct. Now we're looking at on a $45,000 truck, we're looking at payments of $260,000 every single payment. That's not going to be correct. And if we put that in percentage formula, we're going to take this interest rate, put it in percentage formula. Now it's 579% interest. So be careful of that. So if we go ahead and put this back in number, whenever you're typing in interest rates, you want to make sure that you have it 0.0579. And then to make it look aesthetically pleasing, then you can go back in and say, all right, percentage formula. All right, so now we have this $45,000 truck, an interest rate of 5.79%, and we need to make 6 years worth of payments. And we want to have this being paid monthly, so 12 times per year. So before we said, all right, we need to make sure that we have the number or the interest rate divided by the payments per year. Whenever we talked about the rate, we said the interest rate divided by the payments per year. Well, I'm going to show you if we didn't have that divided by the payments per year, what it would look like. So we say equals PMT. And before we said we wanted to do the rate. Now remember, the rate is actually the rate divided by the number of times per year. But for now, we're going to do it where it's not and show you the difference. So we do the rate. And we do it, the next part is the terms. So the terms is how many checks you're going to write on that truck. And we said that that number of terms is going to be 6 times 12, or 72 terms. You're going to write a check for that truck every single month for 6 years. Do the math, that's 72 times you write that check. Whenever you talk about the number of periods or the terms in notes, it is how many times will you make a payment on that vehicle or on that note. In this case, it's 72. We're going to go ahead and do this times this. The next aspect it was looking at was, what is the principal? Remember, we had to say negative that principal value. Because we did not take that interest rate that we said right here, and if you remember on the actual payments, we took the interest rate divided by the number of times per year. In this particular example, we did not. And it's saying that every single month for 72 months, we're going to be making a payment of $2,651. That doesn't make much sense, that for 72 months you make a payment of over $2,000 on a $45,000 truck. If you start coming up with these outrageous numbers like that, go back and check your formula. Because what we have to do is we have to take the interest rate divided by the times per year. And that has to do with the fact that it's being compounded monthly. And you're looking at an APR of 5.79% divided by the compounded monthly aspect. Now we come up with the correct payment. So we have this, we created this whole spreadsheet on this land note, and then we just copied it over to the truck note, and we have everything already all set up. But what you want to do is at the end of this 35th note, at the end of the 35th term, you still have a remaining balance on your vehicle. Well, that would make sense because we're making 72 payments, not 35. So what you have to do in this scenario is you want to go ahead and drag those terms, those number of payments on down. We're going to get down here, all right, that's 70, go 71, 72. Then you want to go ahead and highlight this last row. You want to drag it down. And at the end of that 72nd term, we see that we have a ending balance of $0. So what we want an ending balance of 0 on these notes, which is exactly how we want it to show up. Now, here's another thing that you need to be cautious of. So we come up here and we figure out, all right, what is the total payments per year? Well, before on the land note, it was 1 payment per year. So the payment was equal to the payments per year. In this case, we are making, say, 12 payments of 741. So what you want to do is you want to come up here and you want to take the number of the total payment times the payments per year. That comes out to be you're paying $8,895 per year on that particular vehicle. Now, we come right here and we just copied it over from the other sheet, and now we look at these total payments, and this total payments is equal to almost $26,000. The principal payment on the vehicle was over $45,000, or was $45,000. How can the total payments be less than the actual principal of the note? Well, we know that something's not correct there. So what you have to do is you click on that formula and you go look and you start figuring out, hey, what exactly is going on here? And then we scroll down and then we see, oh, look, we're still basing this off of the previous formula. This formula does not go all the way down to this 72nd term. So in order to correct that, you just come in here, you delete the whole deal, and you say equals sum, open parenthesis, and you just highlight everything going down again. Because we want to include all of the payments on that particular vehicle, because this is the sum of the total payments. And now we see that we pay a total of $53,000 on a $45,000 note. So our interest that we wind up paying is equal to the total payment minus the principal on the note. So we wind up paying $8,000 in interest over the course of the 6 years on this particular truck. Now, let's go ahead and do one more quick example, and we're going to talk about quarterly payments. So, we're going to go ahead and duplicate this again. And we're going to say truck note quarterly. And let's say that you buy this truck, it's at $45,000, interest of 5.79. We're not really changing anything, but we're going to change these payments per year from monthly to quarterly. How do you do that? Well, quarterly means you're paying on this payment 4 times a year. Monthly means you're paying 12. So you just go in here in this payments per year and you change that to 4. So what does that mean? And we see that all these numbers automatically change and update for us. Well, now that we're paying 4 times a year, that means we're only going to make a total payments of the number of years times the payments per year. So we're making 24 individual payments on this note. So let's go ahead and look. Now we come down here to payment number 24. Lo and behold, that's when it goes to 0. So everything below the 24th payment is irrelevant now. So if you create an amortization table that looks like that, you want to come right here and go down and just go ahead and delete all this extra information. And we want to go ahead and make sure that these values are right. So we want to go ahead and sum all the way up to C30. So what I'm going to do is I'm just going to delete these two numbers. I'm going to say C30, and that goes all the way to that bottom cell. And you just press enter. And then we see that now we're paying a total of $53,000, or almost $54,000, and we're paying $53,000 whenever we're paying quarterly. Now I want to make a note right here. We want to say total payment for quarterly. And then we want to say total payment for monthly. So we looked at two different vehicle notes. One was being paid quarterly, one's being paid monthly. So the total payment for the quarterly is equal to this value right there. So the total payment for the monthly, that's going to be equal to this total payment right here under this monthly aspect. So all I did was cell reference back to the other sheet. So this was the total payment for the quarterly, this was total payment for monthly. And as we can see, total payment for quarterly is actually higher than total payment for monthly, saying that this cell is actually slightly higher than this one. So if you paid your truck using monthly payments, you would actually pay off that truck, and you'll pay it off in the same amount of time, but you'll actually save $214. Well, how is that possible? How are you saving money by paying quarterly, or paying monthly, I mean? You save money by paying monthly because you pay off that note a little bit faster. So what I mean by that is, alright, say for the first, at the end of the first 4 years, that note, this is for this particular, for the quarterly one, at the end of the 4th year, you have $38,535 remaining on that vehicle. Let's go back and look at the end of the first year on a monthly note. So that would be end of the 12th year. It's going to be slightly less, or it should be slightly less. Actually, in this case, it is slightly more. But what happens is, you begin to pay it off just a little bit faster. As the further you go, the more months go on, you pay it off a little bit more, and you actually knock down that interest payment a little bit faster, meaning that you actually pay it off quicker by paying quarterly rather than monthly. So the more often, so what happens is, whenever you're paying monthly, you're paying down the note faster, and by paying down that note faster, you actually decrease the total interest that you're going to wind up paying, therefore decreasing the total payments. So you wind up being better off by paying monthly or more frequently than you are whenever you're paying, say, yearly or, say, quarterly. But overall, this gives you a brief understanding, or it gives you an understanding of how to create an amortization table and how to use that to evaluate the loans that you may possibly make in the future, or to evaluate any loans that you've already made, or maybe you become a loan officer, and this gives you a good foundation of why compounding interest works the way it does.